viewers, this video lecture is for the subject Theory of Computation and for the topic Conversion from NFA to DFA from the second unit. And the objectives are to understand the properties of deterministic finite automata and non-deterministic finite automata and to do the problems to convert the NFA into DFA. First of all, we should remember the properties of NFA and DFA. DFA means deterministic finite automata where the state transitions are determined. That is, from a state for a specific input symbol, only one state transition is applicable. But in NFA, for a specific input symbol from a state, more than one state transitions are applicable, and in NFA, state transitions will be performed without consuming any input symbol. And we are going to see the method, subset construction method, which is a standard method for converting NFA into DFA. If NFA has n number of states, the resulting DFA may have up to 2 power n number of states. NFA can be class maybe of two types, NFA without epsilon Mohs and NFA with epsilon Mohs. Now we are going to see the properties for NFA without epsilon Mohs. Every state of DFA will be represented by some subset of states of NFA. And the procedure is, first step is we will check for all transitions from initial state on every input symbol in epsilon, in sigma. Sigma is the set of input symbols. And we will repeat the step 1 for every new state. If a transition on some input symbol resulted in a set of states, then it is also considered as the new single state. We will repeat the step number 2 until no new states are left. Then in step 4, the final states of equivalent DFA are all those states which consist of at least one accepting state of given NFA. Then we will assume the formal definitions for NFA to the corresponding DFA. Then if NFA is equal to is the set of tuples of capital letter Q, sigma, delta, Q0, comma F, then the same thing will be considered for DFA as Q dash, sigma, delta dash, Q0 dash and F dash. Now we can see the problem. Construct NFA that accept all the string that end in 0, 1. Also construct DFA for the same language using the subset construction method. First of all, we have to construct NFA for the given condition. The condition is the system have to accept the language with the input symbol 0 and 1, and the condition is the string should end in 0, 1. So when we draw the state transition diagram for NFA, simply we can draw it with considering the condition ending substring is 0, 1, and rather than DFA, we no need to draw all possible edges from each state for all input symbols. So simply we can draw like this. That is, since our basic string is 0, 1, we can list out all the possible strings like 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, etc. But our basic string is 0, 1. So we may need 3 number of, that is 2 plus 1, 3 number of states to draw the system. So we have to put 3 states, Q0, Q1, Q2. Q2 will be our final state. Then we can put the basic string symbols in the edges. That is, from Q0 to Q1 we have to put 0. From Q1 to Q2 we have to put 1. Q2 will be the final state. Then for adopt other strings, we can put the self loop on Q0 with the input 0 and 1. So we can put more than one label for the edge in case of NFA. And when we read out the possible strings, we may get like 0, 0, 1, 0, 1, 1, 0, 1, etc. So the sample strings by adopting this particular diagram is 0, 1, 0, 0, 1, 1, 0, 1. Now we have to draw the transition table from the diagram. That is, for the input symbol 0 and 1, we have to list out the number of states 0, Q0, Q1, Q2. Inside the cells, we have to write the resultant states. For example, by applying 0 to Q0, we are getting two states. One is Q1, another one is at the same state Q0. In this way, we have to fill up the table. And next, we are in this problem. Additionally, we are going to check one sample string for this state transition function. We are going to check whether the string is acceptable by this table and diagram. So the sample string is 00101. So we are going to use the extended transition function, that is del of starting state is Q0. So we have to apply one by one input symbols, and finally when we complete all the symbols for the string, we can identify whether it is acceptable or not. So del of Q0 comma 0 is equal to, we have to substitute the values from the table. And in the second step, we have to add the next symbol 0. So del of Q0 comma 00 is equal to, we have to separate the del function like this. Del of Q0 comma 0 comma 0. Then we have to apply the value, substitute the value for del of Q0 comma 0. Then we have to separate the del transition functions with the help of union operation. Then we have to substitute the values, and we have to do in this manner. We have to apply the next symbol, and we have to do the expansion in the right hand side in the same manner. And finally, when we apply all the strings, we are getting the final set of states Q0 comma Q2. And in this set, we have to check whether any one of the state is our final state. Yes, we have reached one of the state is Q2, which is our final state. So we can tell our string is acceptable string. Now we are going to do the important operation, that is, we are going to derive the DFA from the given NFA. And the formal definition of DFA is Q dash M dash equal to Q dash sigma delta dash Q0 dash and F dash. Then we are going to derive the help of delta function as per in our theorem, that is del dash of Q0 comma 0 equal to del of Q0 comma 0. When we substitute the value from the table, we are getting the set of states Q0 comma Q1, which is new state. That is, it is the combination of states, it is the set of states which is the new state, which has to be considered in the combined format in the DFA. And del dash of Q0 comma 1 equal to del of Q0 comma 1, which is Q0, which is the old state that is available in NFA. Similarly, we have to find out the del dash function for all the combinations of states available in the NFA, like del dash of Q0 comma Q1 comma 0, del dash of Q0 Q1 comma 1, del dash of Q0 Q2 comma 0. So we are taking delta function for the combination of Q0 Q1, Q0 Q1, Q0 Q2 for both the input symbols 0 and 1. And we are checking the resultant set of states are old state or new state. After deriving this, we have to draw the table for the given DFA. We are going to reconstruct the NFA into DFA. So in the table, we have to write the states as the combination. That is Q0, Q0 Q1, Q0 Q2. And inside the cells, we have to fill up the answers from the previous derivations. And from the table, we have to draw the diagram, transition diagram. So here, when we draw the vertex for the state here, whenever necessary, we have to put the combination of states in a single circle. That is, our set of states are Q0, Q0 Q1, Q0 Q2. We have to draw in this manner. Then we have to apply the necessary edges from the table, like Q0 having the self loop with the symbol 1, Q0 having the edge 2, the next state with the label 0. And when we apply 0 to Q0 comma Q2, we are getting the state Q0 comma Q1. And when we apply 1 to Q0 comma Q2 combined state, we are getting the state Q0. So from the derivation, from the state transition derivation, we can able to draw the table, and from the table we can able to draw the diagram. So this is the resultant TFA for the corresponding NFA system. DFA means we have to draw the state transition diagram. That's enough. And the university questions are like the problems to convert the given NFA to DFA. Thank you.